All right. I had started to have another discussion with Nobel physicist and professor Brian Josephson, and he has a preprint that was rejected by arXiv out of Cornell because they because their academic firewall, and it's really tragic that the Josephson junction is used in all sorts of technology. It keeps being used, but there seems to be a mystery about it because his latest preprint, he's talking about phase space as defined by the transcendental number pi, which is essentially, the ratio of the diameter to the circumference. And I think I got that right. But he calls this, he's citing Yardley, this lady that he corresponds with, who calls it like circular theory because it's the origin of phase. And his whole Josephson effect that he discovered based on superconductivity. I was reading the 1966 Scientific American article that is explaining his Josephson effect. And I didn't finish reading the whole article word for word because I was looking for his profile with John Horgan, and that was behind paywall, so I posted that to my blog because Professor John Horgan, he sent it to me because Brian was asking me to check it out, and then anyway, I sent it to Brian, and Brian was happy about this because John Horgan said that Brian's ideas sound more reasonable to him now. So the Yardley paper, this idea of phase, I asked Brian a question about this, and he responded back. He's like, well, it doesn't really say what you're claiming it says. And it has to do with the center of the circle being 0. And if you think about it, this goes back to the Pythagorean theorem. So we're told that that pi is transcendental as a ratio, but that's assuming that the center of the circle is 0. In terms of the equation for the circle, as tied to the Pythagorean theorem and the right angle triangle. And so then I had noticed that Arthur Young, he talks about Gauss using the Argand diagram for the square root of -1. So what that means is between 1 and -1, instead of the midway point is not 0, but rather it's the square root of -1. And so I was claiming to Brian Josephson that this means the center of the circle isn't 0 anymore. it has to be the square root of -1. And Brian's like, well, no, that's not what Arthur Young was saying. But if you look at the Argand diagram, the circumference of the circle is actually a dotted line because it's a complex number. So it's a process of in time. So it's like 4D space-time. And Brian was having this discussion with Jack Sarfati about the special relativity. And so saying that, you need to separate time from space in special relativity. And when you do that, it affects the speed of light as a constant. And this enables you to have these, I'm elaborating, I don't know the details of what his discussion was, but he was saying that, that corroborates Jack Sarfati's claim a bit about the EPR equals ER conjecture about the wormhole equaling a micro black hole, because you can have a superluminal signal if time is separated from space. And I pointed out to Brian, I said, well, yeah, that's what Olivier Costa de Beauregard was saying. His whole point was retrocausality is based on time being separated from space. And so so then I went back, I said, well, Brian, actually what I was talking about was, thinking of this circular equation for the circle from the Pythagorean theorem being non-commutative. And this is what math professor Luke Hoffman talks about. So first I sent Brian Luke Hoffman's blog, but it's not really detailed in the blog. So then I found Luke Hoffman's paper where he's talking about the Pythagorean theorem being actually non-commutative. And so I was reading that again, and he uses this concept of square zero. So zero, the center of the circle, it's not actually zero, it's actually square zero. And this concept of square zero, it's due to this non-commutative process of 1 and -1 with the square root of -1. And what that means is that every time you make an observation, or there's a measurement, a detection of a change in time, that detection itself causes a change in time. So there's a difference between the measurement and the observation of the measurement. And when you include that, then you can actually derive the special relativity from the Pythagorean theorem. And you can also say that it's the same thing that Dirac was talking about for using for the spinors, the relativistic spinors being based on the imaginary number. And this is also the quantum potential of David Bohm. It's due to the imaginary number that it gets that phase, the imaginary phase normally gets canceled out when you square the amplitude in quantum physics for the location of the particle and the momentum. So if you just have time and frequency, then you still have that -1 or negative I as the imaginary phase of time that inherently can't be seen. And this means that zero is inherently square, like the idea of squaring zero, what Luke Hoffman calls square zero. is this algebraic process in the fifth dimension of time and frequency. And I had suspected this when I was learning, when I was like in 10th grade. I was in 10th grade, so I don't know how old I was. I was maybe like 16. And I knew enough music theory to know that the Pythagorean theorem actually was from the wrong music theory, and therefore it was the wrong mathematics, but I didn't know the details yet. And of course, Alon Khan explains the truth of music theory being non-commutative. And so music theory is the origin of the real number continuum. And so there's a problem in the logic at the origin of mathematics. It has to do with phase. And this gets back to the Josephson effect, because what he realized is that the phases cancel out as a because they're the opposite phase. They're 180. So it's like the sphere is symmetrical. Because the sphere is symmetrical, then on the opposite sides of the insulator, you get a self-amplification of the entanglement between the insulator, and that's what creates the current through the insulator. It creates the voltage, or it creates the charge, or that's the direct current Josephson effect, and then the alternating current Josephson effect creates the voltage, as far as I understand it. But that gets you into the imaginary time, because the phase is alternating in the fifth dimension. So in Brian Josephson's Nobel laureate speech, he says how his Josephson effect relies on space-time symmetry breaking in order to create the current. But what Alon Khan and Luke Hoffman are pointing out is there's a deeper level of asymmetry that's just pure time and frequency asymmetry before space-time. So I'm just going to leave it at that. Thanks.